everybody for attending. Just want to give a quick thank you, and appreciate everybody taking the time out of their day to run through this information here. And certainly hope that this is helpful and really encourage any questions or comments that you may have. And again, my name is Jordan Bunting with Questec Solutions. So today's discussion. So what we're going to cover is our product lines, market overview, why using Questec could benefit you. We're going to cover sight glass for Nace applications, LED illuminators for transparent sight glass, magnetic gauges for interface applications, and float chamber branch connections on a magnetic level gauge. So as far as our product lines, you'll see across your screen here, several different products. And with Questec, we are very, laser focused on liquid level. So you'll see we offer many different product lines, but they're all liquid level. And that's really a strength for us in that, the size of our organization, it's not a really big company, it's not a really small company. But what we've done is we've offered several different level products, and then we branch out into different markets. So we're heavily in refining and power generation. Those are probably our two biggest markets, but we're in all forms of oil and gas, chemical plants, wastewater utilities. We are very prevalent in different markets. But it's great that we're solely focused on liquid level. So we really handle a lot of tough requirements and have a lot of capabilities around that product group. So why use Questec? So as far as our capabilities, we have over 40 different weld procedures. We have many in-house level 1 and level 2 visual weld inspectors. We offer a full range of non-destructive examination as far as testing all of our welded products. We are an ASME stamp holder. So we do hold a ASME S, R, and U stamp. So an S stamp would be what a boiler manufacturer would certify the boiler to. So even though we're not required to have these stamps as the level gauge manufacturer, we have obtained those just to add to our credentials. But if you do need any piping or level gauges that do have a certified stamp, that is something that we could offer. And of course, we design and construct to ASME 31.1 and 31.3. And so our capabilities are there. We have a really wide range of capabilities. Another big asset for Questec is our expediting capabilities. So that's something that's really an advantage for us in that, we can get things out very quickly when needed. So oftentimes our standard lead times are really good, but we can also improve on those standard lead times. So I included an example here of a recent opportunity that we had to solve an issue at a refinery. So they, in your lower left here, you'll see this is a replacement float and indicator we made for a competitive brand. So we originally quoted these parts in 1 week, and the plant contacted us and said, hey, they can't wait a week, they have to have it ASAP. So we actually turned around these parts in 24 hours. So we were able to help the customer in getting their gauge back up really fast. And again, these parts were not for a Questec magnetic gauge. They were for a competitive brand, but we were able to work with a customer and determine the float chamber size and schedule to make sure the float would fit. We confirmed the specific gravity, pressure, temperature of the application to correctly engineer the float, and then we also provided the replacement indicator. So Nace applications. So what we're going to run through here is what we do for a sight glass in a Nace service. So Nace is the National Association of Corrosion Engineers. It's an international group that publishes a wide variety of material and testing standards. So they have numerous, material standards and testing standards out there. Our products are mostly designed around Nace MRO 175 and Nace MRO 103. So those two standards are what we see on a regular basis. So 0175 came out in 1975, and it's for materials used in H2S environments. And then MRO 103 is material resistant to sulfide corrosion cracking. So, those two Nace standards are what are brought as a requirement for Questec products on a pretty regular basis. So what does Questec offer for Nace applications? So obviously we offer the compliant materials that are required by the end user. We also offer options that greatly improve reliability. So, because these are very, dangerous applications and very dangerous conditions, if there are leaks, we can do things with the sight glass to make it more reliable. Example of that would be, eliminating unions, eliminating nuisance leak points like threaded connections. So there's things that we can do outside of what's required in Nace. And Questec also offers all the testing and documentation related to Nace requirements. So Nace material combinations. So at Questec, we really have two material combinations. We offer Nace wetted parts and Nace environmental. So the wetted parts, pretty basic, all parts that come in contact with a process fluid. Nace environmental would be all the wetted parts, also with the bolting combined. So those are the two different material combinations. So Nace wetted. So just to use a Nace MRO 103 as an example, Nace Nace spec has 16 material groups, and within each material group, several different material grades comply with that group. So when you look at carbon steel, for example, that's a standard material for Questec. The various different carbon steel grades that we manufacture from, comply with the MRO 103 carbon steel material group. So those material grades, A105 carbon steel, what we would use for the valve body, A696 grade C carbon steel, the material that we would use for the sight glass chamber, and the A106B pipe nipples. So all three of those different materials, comply with that carbon steel material group in Nace. So those are all the wetted parts. So Nace environmental, that's where we would also include the bolting as a wetted part. So this is kind of one of the overlooked areas, in my opinion. This is one of the areas where this is one of the areas where knowing how the gauge is going to be installed will determine, how we provide the Nace compliance. So the basic simple area is if the gauge is going to have an insulation jacket, Nace says that bolting is now considered a wetted part. So in Nace 5.2.1, it describes that if the bolting is buried under insulation, they now consider that a wetted part. So this is, an area that's kind of overlooked. It's a little bit complicated in that Questec Solutions, as the level gauge manufacturer, we may or may not know if the gauge is going to be insulated. If we're providing the insulation jacket, that makes it easy for us to know that, yes, we need to have that M-grade bolting. But that is something that, I see as something that sometimes it's overlooked. But again, if the gauge is going to have an insulation jacket, Nace considers that bolting a wetted part, and that's where you have to comply with that bolting material table. So here at Table 8, common bolting materials that meet Section 2 and Section 3 requirements, you'll see the M-grade bolting listed below. So as far as other options that we can provide for Nace applications, an all welded sight glass is something that we're seeing more and more of, where in the field, in the unit, you might have a sight glass that has, threaded connections and may have union connections. And it's very common for us to provide a in-kind replacement assembly. However, that replacement assembly can be built to more modern specifications. So this is something that we see quite a bit for Nace applications, where there's some improvements that can be made by when the gauge is going to be replaced. So at a typical refinery, you'll have gauge replacements, because the glass is dirty or the gauge is leaking, and either a rebuild of the sight glass is going to take place or a replacement of the sight glass is going to take place. So if you're going to replace the sight glass, that gives you the opportunity to improve the way the sight glass is manufactured. So we see a lot of this happening at various refineries throughout the US, where we're building a sight glass to fit the existing dimensions. However, we're eliminating unions and we're eliminating MPT connections. So that greatly, increases the integrity, it greatly increases the reliability of that replacement gauge. So this is just an example of one that we've done out in the field, where you'll see this process connection was flanged, which really worked out great. And that way the customer didn't have to weld in a flange in the field. We could bolt right to that and eliminate that union that's unnecessary there. So another common requirement that aligns with Nace is post-weld heat treatment. So Nace does not require post-weld heat treatment for our carbon steel manufacturing or carbon steel welding, but this would be a customer requirement. So, if the customer specifications in a certain service or in Nace applications, if those requirements call for post-weld heat treatment, that's something that we offer and are very, very familiar with. So, why is post-weld heat treatment done? It's basically a method for reducing and redistributing the residual stress in the material that have been introduced by welding. So, benefits of post-weld heat treatment. At higher temperatures, when you hold the heat treatment at a higher temperature, it permits some tempering and precipitation effects to occur. So what this does is it has a metallurgical change in the material, and it reduces the hardness of the material. So it improves ductility and reduces the risk of a brittle fracture. So post-weld heat treatment, this is an in-house capability for Questec. We actually operate our own oven at our facility. And these are just a few photos of jobs being processed through the shop. So again, it's heat treatment is available by end users, or I'm sorry, is required by end user for carbon steel material. With Questec having numerous weld procedures, we do have other material that part of the weld procedure, the the heat treatment is required. But for standard P1 carbon steel, we do have a weld procedure without heat treatment, and we have a weld procedure with heat treatment. And again, that's driven by customer requirements. Brunel hardness testing is a way of testing and showing that the welds have reduced their hardness. So when we do post-weld heat treatment, Brunel hardness is also another question or another area that we need to inquire about. So is there hardness testing required? And if hardness test is required, what are the percentages? So this is just an example specification here where these requirements in just an example job called for a heat treatment at 1175 F and called for a 2-hour hold time. And part of the documentation requirements of the job were to have Brunel hardness test results. So when we do hardness testing, we have to know what is the acceptance criteria. So we can run hardness tests on a given weld, but we need to know what is acceptable and what is not. So Brunel hardness number is something that we will ask for. So generally 200 Brunel hardness is what we see as the most common maximum hardness requirement. We also will see 225. So testing percentages. So in the previous slide, we talked about Brunel hardness is available in 5% to 100%. So the reason why we ask about testing percentages is each job is different. If we're manufacturing just one single sight glass, you're going to have approximately 10 welds. Now, some of the other complex jobs that we'll tackle, could be a complex bridle assembly, and in that example, you could have over 100 welds. So that's one of the reasons why we ask for to define the percentage of testing on each weld. So there's obviously a great cost impact and labor impact if we were to take a bridle assembly that's got 100+ welds and do a Brunel hardness test on every single weld of that assembly. That would really have a cost impact and a duration impact. Versus on a sight glass, if you're just looking at one sight glass assembly, if you've only got 10 welds, it's not, laborious process to, do 100% testing. So that's the reason why we like to define testing percentages. So vent and drain accessory valves. So when we're providing a replacement sight glass, it's very common for us to provide a turnkey assembly. So if there's any additional accessories that need to be welded to the assembly, when we complete all the testing, when we complete the hydro test, all those welds are tested. So it's very common for us to receive a pipe valve fitting specification when we're handling a Nace job, where we're going to include vent and drain valves as part of the assembly. So most common would be, a socket weld bi-threaded, bolted bonnet, class 800 gate valve. So I'm going to actually pause here for any questions. Do we have any questions in the group at this point? Anything with Nace requirements that anybody's curious about?
Jordan, this is Will. We do not have any questions currently. Just want to remind everybody, if you do have any questions, please send them in the chat and we'll answer them as we go. So you're good to go, Jordan.
Sounds good. Sounds good. Okay, so now I'm going to move on to illuminators for transparent sight glass. So why use an illuminator? It does allow operators to see a liquid-liquid interface. If you're using a reflex style sight glass, it's only going to show total level. All liquid is going to appear the same. So, you cannot use a reflex gauge for interface. But using a transparent with an illuminator really enhances that liquid-liquid interface. So it does make the level easier to see. So it also improves plant safety and allows the operator to view the level from a further distance. So those kind of go hand in hand. If you have an operator out in the field and the level is difficult to see, what you can get is somebody trying to get very close to the gauge to see where the water level is or see where the liquid level is. And if somebody's allowed to stand further back, it's just a safer position for an operator. Some liquids are very difficult to see. If you have a clear liquid inside of a chamber, you're going to see clear where there's no liquid. You're going to see clear where there is liquid. It could be hard to see that meniscus line in between the liquid and gas phase inside the sight glass. So an illuminator will also improve the visibility of the level if the glass is dirty. Over time, what can happen with a sight glass is the inside of the glass surface can get a buildup of sediment or debris, and that sediment that gets stuck to the inside of the glass can make it hard to see the level. But when you light up the inside of that chamber, that makes that liquid level much easier to see as that sediment could build up on the glass. And it also improves level observation in dimly lit areas. So it allows somebody to see the level or see the sight glass, see the level in the sight glass, no matter what time of day it is, if it's dawn, dusk, or if it's simply just a dimly lit area. These LED illuminators that we manufacture, the LEDs have a very bright intensity, so it really makes it easy to see the liquid level. So as far as requirements and benefits, the gauge must be transparent to backlight the chamber inside. So we do not offer an illuminator for our reflex gauge. It's really not going to work that well. You're better off, if you have a reflex gauge, you're better off installing a light in that area to illuminate the entire area for safety. With the power supply, it's either 115 VAC or 230. Obviously the 230 would be more of a European spec. LEDs offer excellent longevity, low heat generation, and low power consumption. Questec, we've been manufacturing our LED illuminator for almost 20 years now. And we have replaced a lot of the old style illuminators that have the incandescent bulbs that are just troublesome to maintain. And of course, our illuminator in standard is rated class 1, div 1, BCD. So it's rated for hazardous environments. So specifying an illuminator. So it's very, very easy to specify these illuminators. They're designed to fit on any manufacturer. So the basics we need to know are the glass size, the number of sections, the voltage, and any add-on options. So with these sight glasses, we may manufacture our sight glass using industry standard size glass. So we need to know what size the glass is, size 1 through 9, and then how many sections there are. And then that tells us, that completes most of the model. So, this example here, it's a size 6 gauge, it's 2 sections. We're using 115 VAC, And that pretty much completes the model from there. And if there's any other add-on options, that would be included in that model number. But again, these illuminators are made to fit industry standard size glass. So if you happen to have an oddball size gauge where somebody took two different size gauges and piped them together to make one longer sight glass, we do manufacture non-standard sizes. So how to specify an illuminator for an interface application. So if you're using the sight glass in an interface application where you've got two different liquids, we do recommend to use white LEDs. So you'll see that photo over here where that's showing you the lighter liquid on the top, heavier liquid on the bottom here, and using white LEDs will really bring out the color characteristic of that liquid. So in our model, we do have an area where you can designate white or green. Green LEDs are our standard, white is optional. So how to mount an illuminator. So this is a kind of a side view of the illuminator showing you how it mounts in the back of the transparent gauge. So the benefit of our design is we do not use clamps to grab on to the gauge cover. We use a stainless steel lanyard material that wraps around the gauge. So some of the clamp designs that are out there, if that clamp ever loosens, the illuminator can fall off, or can be very difficult to see the level, because if the illuminator shifts left or right, you're going to lose that light path inside that chamber. So our illuminator is very, very easy to mount on the gauge. So it doesn't require any tools. There's no special tools that you need to use or buy. It simply wraps around the gauge, and then you tighten the lanyard eye bolt with a wing nut that's on the back of the illuminator. So it's very, very simple to mount that illuminator, take it on and off in the field. No special tools are required. So power supply positions. So this is also something that Questec can customize. So we have a standard power supply position where when the illuminator is mounted on the back of the transparent gauge, the power supply is at the top. So we do offer, alternate power supply positions, for various different reasons, whether it's a clearance issue, could make it, easier to install. And then also length is a factor as well. So these illuminators, we could manufacture an illuminator that, this thing could be 10 feet long. And if the power supply is at the top, that might make it very difficult to install. Versus if the power supply is at the bottom on a 10-foot illuminator, could make it much easier to install. So we do have different power supply positions that we can provide. So that just gives you kind of a side view of what our mid mount looks like and what our bottom mount looks like. So I'm going to kind of pause here. Do we have any questions?
Yeah, Jordan, we have
on illuminators for transparent gauges.
We do have two questions here, not specific to the illuminators, but first question is, how quickly can I get an approval drawing and then delivery on a custom gauge?
Okay, so approval drawings. So with Questec being solely focused on liquid level, we are flexible. So we do have a standard approval drawing lead time. Generally, approval drawings, our standard would be 5 to 10 working days. However, if the approval drawing is needed quicker than that, we can do approval drawings in 1 to 2 days. So it is something that's we're able to expedite. So we do have standard approval drawing lead time, but we also can expedite those drawings. And with our product, with us offering a lot of custom configurations, the support that we provide early on in working with the customer is something that we really embrace. So we really embrace working out the details to get you that approval drawing. In your everyday example, our equipment can be very challenging to specify. So because it can be challenging to specify, we really know the right questions to ask early on to get all the, kinks worked out for us to do the approval drawing quick. But as far as us physically creating that drawing, I've seen us do it on numerous cases, 1 to 2 days. But if it's a very complicated job, it might be 3 to 4 days to get that drawing done. It just depends on the assembly at hand. For example, if we're doing this very complicated bridle, that approval drawing would take longer. If we're doing a, one sight glass that's got some pretty basic options, we can get that out pretty quick. And as far as lead times, the second question, as far as lead times on a custom assembly, I would say if there's a lot of requirements, if there's a lot of non-destructive examination, X-ray, say there's steam tracing, insulation jacket, special coating, that's more around 6 weeks for a custom sight glass. However, with our ability to be flexible, we could move that into more of a 4-week lead time, and say that there's an urgent need to get a custom sight glass quick. We can actually look at how can we meet the customer's requirements, how can we meet the plant's requirements and also meet their lead time. So sometimes, we don't have the time to do insulation jacket, or we don't have the time to do external steam tracing. So sometimes we can change our scope of supply to actually get you that sight glass quicker. But I've seen us manufacture a sight glass in a couple of days. But again, that just does depend on the requirements. But if you have a need for a custom sight glass that's all welded connections, that has NDEs, has special coating, that you're looking for more around the 4 to 6 weeks lead time.
Okay, we have 2 more here. You mentioned you made a float for a competitive model. Are your glass, valves, and probes all compatible with others?
Yes, in most cases. So there are some caveats here and there with replacement glass. So the actual glass lens that goes inside the gauge, none of the sight glass manufacturers in the U.S. actually make the glass themselves in house. They all buy it from vendors, and the Europeans have really pioneered manufacturing the actual glass lens, and we provide our glass as a replacement for any competitive brands that are out there. So if you have a different brand out there, our glass, if it's not, it could be made by the exact same vendor, but it's 100% made to the same standards. So it's very common for us to provide, say our size 9 tempered borosilicate glass. It's very common for us to provide our replacement glass for a competitive brand. Generally, the glass, the standard glass material is tempered borosilicate, and generally what you have out in the field is industry standard size 1 through 9.
Okay. Thank you. And the
And
last
that would be
one.
the,
Oh, go ahead. Sorry.
and I just wanted to expand on that. Along with the glass, the gaskets, all those parts are also industry standard size. So we can also provide replacements for any brand gasket as well.
Okay. And then actually we got one more that came in. So this next one is, have you had any issues with high vibration areas in the Illuminators, specifically the stainless steel cord mounting, breaking over time or cutting into anything?
No, we have not had that issue. And if the plant had any specific concerns with high vibration, we could work with our engineering department to, include a special feature or address that issue specifically. But with our Illuminator mounting, the Illuminator is also resting on the gauge cover, so it can't move down any further unless it would back off a couple of inches. So we haven't had any issues with the Illuminator loosening with vibration. But if a client is interested in investigating that detail a little bit further, we could come up with a solution to address vibration. But today, I haven't seen any issues with vibration and the Illuminator becoming loose.
Okay. And the last one we have here, what would be the best color illuminator for use with clear hydrocarbon so you get the best contrast?
So that's a little bit difficult to answer because it can kind of come down to an individual's eyesight or an individual's preference. So one person might like green better, one person might like white better. Unfortunately, both of those people might work at the same plant, but it would come down to personal preference. I mean, I would steer somebody more in a white color in that instance, because white is only going to enhance and allow you to see any color, versus the chamber versus the process fluid might just appear green if you're using a green colored LED. So Illuminator color does depend on somebody's visual preference.
Okay. And there's
any other questions so far?
Just a quick one to backtrack off of the compatible with other models. Does that include the probes and valves as well as the glass?
Yes. So as far as conductivity probes for boiler water level measurement, Questec manufactures our own proprietary design probes, but we do also manufacture aftermarket replacement probes. So we design probes to fit other brands out in the field. And the reason we do that is for product support. So because we're known for being able to expedite and provide quick turnarounds, we also offer those aftermarket replacement probes to solve those needs when a customer's in an emergency. And as far as the valves, yes, our valves can replace anybody else's valve. So, sight glasses, the traditional way of specifying a sight glass is with a top and bottom ball check valve. And those valves are most likely going to be an offset type valve. So our offset is the same as one of our biggest competitors. So with that offset being the same dimension, it is very easy for us to replace our valves in the field. It's just that the internal parts of the valve would not be interchangeable. But generally with these sight glass valves, it's most likely that they're going to replace the entire assembly.
Okay, thank you, Jordan.
Any other questions?
Oh, you are good to go, sir.
Alrighty. Okay, I do see another question popping up here on my screen about a solar powered illuminator. So right now, Questec does not have a option for a solar powered illuminator. Right now that's just been due to, lack of inquiries. We haven't had enough customers ask about solar powered illuminator to develop that feature. So currently right now, no solar powered. Okay, I'll continue on here. So now we're going to get into magnetic level gauges. So we're going to talk about some nitty-gritty details here. So what I'm going to cover here is the actual branch connection on the chamber itself. So you'll see three examples here, a set-on branch connection, an OLED branch connection, and a Buttwell T branch connection. So what we're going to focus on today is this Buttwell T fitting here. So Buttwell T branch connections using a wrought T fitting. So again, we're going to get into some nitty-gritty details here, and there's different methods to manufacturing these magnetic gauge chambers, and it's pretty interesting what's out in the marketplace. So one way of manufacturing a magnetic gauge with a butt weld branch connection would be with a butt weld T fitting. The other method is with a pulled extruded pipe. So the Questec method is with a wrought butt weld T fitting. And what are the benefits of that? It does yield a high integrity, very high strength joint. The fitting itself is made to ASTM A403, and that butt weld, that wrought butt weld fitting offers a substantial wall thickness compared to a pulled extruded pipe. When you pull extruded pipe, you're also thinning the wall of that pipe. So the wrought T fitting will improve, corrosion allowance, and it will also not require any derating of the float chamber since you're not thinning the wall. Back up here. So butt weld wrought T. So how are these fittings made? So this is a pretty interesting process. How they make these wrought T's is they are there's different ways of manufacturing them, but these stainless T's that we use, they're either hydroformed in a bulge press, or they could be made by bringing pipe up to forging temperature and pulling a ball through the pipe. But what we're going to focus on is just this the hydroform method. So most of our stainless steel wrought T's are made with the hydroform process in a bulge press. So basically they take a piece of pipe and put it in this machine, and that machine squeezes the pipe in. So it's basically squeezing down on this pipe, and it's pressurizing that pipe and pushing the material through an opening, and that creates that outlet in the side of that T. And then that bulge is machined to a butt weld. So, the benefit of this manufacturing method is it leaves you with a fitting that has a greater wall thickness versus pulling the pipe into a butt weld. So this is the process how they make pulled extruded pipe T's. So it's formed in a collaring machine where they take a stock pipe, set it up in a machine, a pilot hole is drilled, and a special collar goes into that pipe hole, and as that collar retracts, it pulls that pipe wall into a butt weld. So it's pulling and stretching that material and thinning that material. So there's a few magnetic gauge manufacturers out there in the marketplace that really promote and push extruded pipe branch connections. And Questec, we actually worked on having this capability, but as we were working on engineering this capability, we realized that it's really not a good method. Mainly due to the machines that these manufacturers have. They were really designed for Schedule 10 pipe, and what they're doing is pulling that Schedule 10 pipe into a butt weld, resulting in a thinner wall at that curvature of the pipe. So here's a side-by-side comparison here of a hydroform butt weld T-fitting versus a piece of pipe that's had a butt weld pulled into the side of the pipe. So this example is on a 2-inch Schedule 40 pipe. So this side-by-side comparison, you'll see right here, the thickness in that curvature is 0.175. And the wall thickness for 2-inch Schedule 40 pipe is 0.154. Here at the curvature on the pulled extruded pipe, you'll see it's actually been thinned at that curvature below what the standard wall thickness is for a 2-inch Schedule 40. So this is actually a real world example in a piece of 2-inch Schedule 40 that we pulled at our factory. And since we were able to do that in-house, we were able to take measurements here along that area of the curvature of the pipe. So there's substantial difference between a butt weld T-fitting, a fitting that's specifically made, versus taking a piece of pipe and pulling that pipe into a butt weld. So here's some failures in the field. So these are real world examples where we've provided replacements for issues, or we've helped a customer identify where the issue is coming from and how to specify a gauge to avoid that in the future. So these are 2 pulled extruded weld failures, and you can see the weld cracked at the outlet of the pipe. And that's right where that butt weld is pulled and formed in the side of that pipe. So how to specify a butt weld T-fitting gauge. So this is kind of tricky with different verbiage. So when somebody says, I want a magnetic gauge with a butt weld branch connection, both a pulled extruded pipe could apply to that, and the T-fitting could apply to that. So somebody says, I need a butt weld branch connection, both could apply. If somebody says, I need a full bore branch connection, both that pulled extruded pipe and the T-fitting would apply to that. So this is an example of how to specify to ensure that what your vendor is quoting you is a wrought butt weld T-fitting. So this is just an example on a data sheet where it's calling out the chamber branch design, and the exact verbiage is a wrought butt weld T-fitting. So if you were to simply say, I want a butt weld outlet, both methods could apply. If you were to say that I want a full bore outlet, both methods would apply. But specifically calling out that fitting is what's going to ensure that you're going to get a wrought butt weld T. I've also seen a few specifications where in the notes section, they specifically define that a pulled extruded pipe outlet is not permitted. So this is just, again, how to specify that. So do we have any questions on on the material that we just covered for the branch connections. I know it's kind of a nitty-gritty detail, but it's a very interesting way of specifying a magnetic gauge.
We do have 2 questions currently. Let's make sure I don't miss any more. First one is going back to the Illuminators. Do you offer DC power for the Illuminators, specifically 24 volts?
Currently, we do not offer a DC option for our Illuminator, and that's been due to a lack of demand. I've only had one other plant request that for one gauge at the plant, where 99% of the gauges at the plant, they use a regular 115. They only had one install where they were asking about 24 volts. So we do not offer a 24 volt at the moment, but we would be interested in hearing about somebody's requirements. So after this presentation, we'd love to talk to anybody about that to find out what their plan is like and what the demand for a 24 volt option would be out there.
Okay, thank you. And the second question I have here is for transmitters. I assume Questec does not manufacture. Competitive gauge suppliers do not either. They ship separately from each other at different arrival times, on occasion causing issues. Also, they need to assemble them themselves, configure and calibrate them. Is this your process as well?
No. So what Questec does is we do not manufacture the magnetostrictive transmitter, and that's very common. A lot of manufacturers private label, or they use the OEM brands. But with Questec, we use MTS for our magnetostrictive transmitter, and what we do is we mount the transmitter at our factory, and we run the transmitter through a calibration check when we do our functionality check of the magnetic gauge. So we do not ship the magnetic gauge and transmitter separately. And we really advise against that, because now if a customer at a plant is having to mount that transmitter, now really the final QC is up to the plant, because they're the ones assembling this stuff, and that magnetic float has to couple with that magnetostrictive transmitter. So all of our magnetic level gauges go through a QC functionality test, and part of that QC functionality test is calibrating that transmitter and validating various points throughout the measurement range. So we ship everything as a turnkey assembly ready to install.
Okay, and then we just have a last comment regarding the DC Illuminator. Just as FYI, not having 24 volts is not really an issue. Might just be helpful for an oddball application. So,
yeah.
Thank you for that.
Yeah, and we appreciate that, and we appreciate that further comment. And that's kind of what we've seen at other facilities, is there's just been a lack of demand for it. Any other questions at all?
Nope, not as of right now. Thank you.
Okay, so this is last topic for today, is specifying a magnetic gauge for an interface application. So here's a good visual showing you a magnetic gauge that's been specifically designed for a liquid-liquid interface. So when you have an application that's got different liquids inside the tank, the float needs to see at minimum a 0.1 difference between the light specific gravity on the upper and the heavier lower specific gravity. If there's less than a 0.1 difference between fluid specific gravities, there's going to be too large of an emulsion layer, and there's not going to be much accuracy with that measurement. So due to the lack of accuracy, that's why we are looking for a 0.1 difference between the two liquids. And when we're processing RFQs and when we're reviewing data sheets, we are looking for whether it's total level or whether it's interface. So both liquids need to be specified on the data sheet or in the request for quote. And it's good to clearly state that you're looking for an interface measurement between the lighter and heavier liquid. So, because we can certainly do we can do an application that's got different liquids inside a tank and still do total level. So we do like to see that it's clearly stated that they want the float to measure the difference between the lighter liquid and the heavier liquid. So basically what we do is we weight the float to sink down past that lighter liquid and ride between the light and heavier liquid as shown in that image there. So we do need both specific gravities, and then we also need considerations for the process connections. So when you have an interface application, you know, at the very least, we're looking for one process connection per phase of the process media. So we're looking for one process connection in vapor, one process connection in the light specific gravity, and one process connection in the heavier specific gravity. So that would be at a minimum. So we've tackled difficult interface applications, you know, with 4, 5, 6 process connections to ensure that that magnetic gauge chamber is communicating properly with the vessel. So since the float is traveling inside that external chamber, it's important that the liquids inside that vessel, you know, communicate with that external chamber, you know, and having those multiple process connections, you know, ensures proper communication with the liquid. And another topic to cover, when we do provide a magnetostrictive transmitter, that magnetostrictive transmitter is only picking up that float. So if you need a signal that's got total liquid, that would have to be done with a separate float in a separate chamber. So that magnetostrictive transmitter is only going to pick up that single float in that chamber. And some of the questions that we do get with a interface application, you know, is, you know, can you put 2 floats inside the magnetic gauge, where you've got one float at the upper total level and you've got one float measuring the liquid-liquid interface. And we do advise against that, just because those floats could actually intersect and you could get false level readings if those floats bumped into each other. So if you are looking to get, you know, total level and interface level with a magnetic gauge, you know, that might be a challenge where you'd have to look at doing either a dual chamber magnetic gauge, where we can actually connect 2 chambers into one process connection or one set of process connections, and have each chamber in its own containment. But yeah, these are just some essential details on how to spec a magnetic gauge for interface. So we can go ahead and open it up for any other questions. I'm not sure if there's any other questions that we can address, either on anything we previously covered in the presentation or in this interface. So any other questions out there?
Yeah, we do have one so far. Could you use a TDR for interface?
Yes. So Questec also manufactures a lot of bridle assemblies, and it's very common for us to provide a level bridle that has a guided wave radar combined with either a Questec sight glass or a Questec magnetic gauge. So, you know, the combinations are really endless. You know, but we do a lot of bridle fabrication or bypass chamber fabrication. So because we really excel at pipe fabrication and welding, it's really common for us to make a chamber for a guided wave radar or a level bridle assembly, where we're combining, Questec level instrumentation. We're combining Questec visual level instrumentation with a guided wave radar transmitter.
Second question we have here is, would a magnetic gauge be appropriate for a liquid CO2 application?
I would have to investigate that a little further. We would need process conditions. So to investigate that, we would need the specific gravity at normal operating conditions, maximum operating pressure, and maximum or minimum operating temperature.
Okay, thank you. Ryan, we can probably dig into that a little bit later.
Okay.
As of right now, we do not have any questions. If you guys do have any quick questions, please send them in. I'll stay on with Jordan for a little bit. But just want to say thank you for everybody for attending. We appreciate it. Hope you guys got something out of this. And Jordan, thank you very much for putting this on. We greatly appreciate it.
Yes, sir. Yeah, I really appreciate everybody's time into attending today.
And if there's no further questions, gotta let everybody go here, but I'll stay on for another minute just in case.